As we discussed in class today about why we need to know multiplying and dividing fractions, recall that we said that any career that involves measuring or measurement will use fractions. And many of them can't round, they have to be precise. And one of the words that we need to know is the word reciprocal. The mathematical definition of reciprocal is any number times its reciprocal equals 1. So for example, if I had 3/4 times its reciprocal, 4/3, that's going to equal 12 divided by 12, which is 1. And what do you notice about the reciprocals here? And this is the elementary way of writing it. And that would be that the reciprocal is the flip, of a fraction. All right, so we're going to try this on some problems. We're going to look at the rules real quickly. When you multiply fractions, you multiply the numerators and the denominators across. And we looked at that today. You simply multiply the numerators and denominators across because we already have them as proper fractions. That's going to give me 8/15. But what if I have a mixed number? If I have a mixed number, then I have to change the mixed number to an improper fraction. So let's look at what this means. 2 and 1/6 would be 6 times 2, which is 12, plus 1, which is 13/6, times the 1/4 is already written as a proper fraction, so it stays. So when we multiply fractions, again, we just simply multiply across here, and that would give me 13/24. 13's prime, 13/24 cannot be reduced, and so I am finished. For division, we cannot divide fractions as they are written, but because multiplication and division are opposites, we can rewrite a division problem as a multiplication problem. And we do that by taking the reciprocal. A way of remembering this would be the phrase, keep, switch, and flip. So we are going to keep the first fraction as is. And then notice that the sign gets switched from division to multiplication. And then we take the reciprocal of, or we flip the second fraction. And then we simply multiply across 15/12. And what do you notice? 15/12 can be reduced. They both have a common factor of 3. And then that is an improper fraction here, so it needs to be rewritten as a mixed number, and this is your final answer. What if we have 2 mixed numbers? It really doesn't change much. We still are going to change, from an improper fraction to a mixed number, from a mixed number to an improper fraction, my fault. And then we have to change that from a division problem to a multiplication problem. How are we going to do that? We are going to keep the first fraction, switch the signs, and flip the second fraction. And then we can multiply straight across. 10 times 4 is 40, 19 times 3 is 57, and that is our final answer. All right, we're going to page 2 of the notes from today. And we should be at the top where it says do it together. You'll notice our first problem, 3/4 times 2/9. It's already written. Both of these are proper fractions, so we can leave them as is. We're just going to simply multiply across, and that's going to give me 6 36. Now, you should notice right away that both of these numbers are even. So they do have at least 2 as a common factor, but the greatest common factor is going to be 6. So we're going to divide the top by 6 and the bottom also by 6, and then that's going to give me 1/6 is my final answer. But I want to show you a different way of doing this. What if I take the 3/4 times the 2/9? And when you're multiplying fractions, you can do a procedure called cross-canceling, meaning I can reduce the fractions that are diagonal from each other, here and here, okay? The ones that are diagonal. So I can look at the numbers that are diagonal, do 3 and 9 here and here have a common factor, and yes, they do, of 3. So 3 goes into 3 one time, and 3 goes into 9 3 times. Now I'm going to look at the other set of diagonals, 2 and 4. They have a common factor of 2. 2 goes into 2 one time, and 2 goes into 4 2 times. Now that I've cross-canceled, I can simply multiply across. So 1 times 1 is 1. 3 times 2 is 6. And we end up with the same answer, 1/6. It doesn't matter which way you choose to do it. However, if you choose not to cross-cancel, you may end up with larger numbers that are hard to reduce at the end. All right. Sorry, there was an announcement. Let's look at the second problem. If you'll notice, the first part of our number is a mixed number. So what's step 1? Yes, we have to change that to an improper fraction. So 3 times 7 is 21, plus 4 is 25/7 times, and we already have a proper fraction of 7/8. Here, I highly suggest that you try to cross-cancel. Otherwise, you're going to end up with large numbers in the numerator and denominator that don't have obvious factors. So if you look across here, I have 7 and 7. They cancel each other out totally. If you divide any number by itself, you're going to get 1. So those actually cancel out to 1. And now I can simply multiply across. 25 times 1 is 25. 1 times 8 is 8, but because that's written as an improper fraction, I have to change it to a mixed number. 8 goes into 25 3 times, which is 24, and that gives me 25 minus 1, 1 out of 8 left over. What do you notice different about the third problem? Well, I have 2 mixed numbers and I have division, so there's a lot to this problem. Our first step is to change both of these to improper fractions. So 3 times 4 is 12, plus 2 is 14/3. Division, so divided by. 3 times 5 is 15, plus 4 is 19/5. Now we need to do what we did in the other problems. We need to keep, switch, and flip. So we are going to keep the first fraction as is, 14/3. We are going to switch our sign to multiplication, and we're going to flip the second fraction to 5/19. Now we're going to look to see if we can cross-cancel, which we can't. So we're going to have to multiply straight across. 14 times 5 is 70. 3 times 19 is 57. I have an improper fraction, so I have to change that to a mixed number. 57 divides into 70 one time, and that has a remainder of 13 out of 57. Okay, let's look at the next 3 problems. Here I'm multiplying, so I'm not going to keep switch flip. I'm not dividing, but the first step I have to do is change them to improper fractions. So 3 times 4 is 12, plus 3 is 15/4, times 5 times 2 is 10, plus 3 is 13/5. Am I able to cross cancel? Yes. 5 and 15 both have a common factor of 5. 5 goes into 15 3 times, and 5 goes into 5 1 time. 3 is prime, therefore, 13 is prime, therefore 13 and 4 cannot reduce. So now I'm going to multiply across, so 3 times 13 is 39, 4 times 1 is 4. I have an improper fraction, so I have to change that to a mixed number. 4 goes into 39 9 times. 9 times 4 is 36, which I'm going to subtract from the 39, and that gives me 3/4 left over. All right, the second problem. I have division, but they both are written in either proper or improper fraction form, so we're going to leave them as is. We don't have to change it from a mixed number. So I'm going to keep my first fraction, 3/5. I'm going to switch my sign to multiplication, and I'm going to flip the second fraction, which would be 4/9. Do I have common factors when I go to cross cancel? And the answer is yes. 3 and 9 have a common factor of 3. 3 goes into 3 1 time, and 3 goes into 9 3 times. So now I'm just going to multiply straight across. 1 times 4 is 4. 5 times 3 is 15. I have a proper fraction that cannot be reduced, so that is my final answer. And then just one more problem for today. I have two mixed numbers, and it's a division problem. So step 1 is to change the mixed numbers to improper fractions. So 8 times 4 is 32, plus 3 is 35/8, divided by 6 times 2 is 12, plus 5 is 17, so that's going to be 17/6. Since I have a division problem, I have to switch the signs, and then flip my second fraction. Am I able to reduce? Yes, I can reduce because 8 and 6 are both even. 2 goes into both 8 and 6. 2 goes into 8 4 times, and to 6 3 times. I am not able to reduce 35 and 17. 17 is prime. So now I need to multiply across. 35 times 3 is 105. And 4 times 17 is 68. And you can do that multiplication off to the side if you need to. I have an improper fraction, so I need to change the improper fraction to a mixed number. 68 goes into 105 1 time. And then I need to subtract. What's 105 minus 60? 45. 45 minus 8 more would be 37. 68. 37 is prime, therefore it cannot reduce to 68. Thank you, and I'll see you guys tomorrow at school.